In today's video, we take you inside one of the complete dismantling of thousands of Typhoon-class submarines, the largest submarines ever built. Welcome to Factory Founder, where we turn history into tomorrow, one recycled giant at a time.
Our journey begins in one of the most extraordinary industrial landscapes on Earth. A vast outdoor junkyard maze where thousands of Typhoon-class submarines lie scattered like sleeping leviathans, their massive grey hulls stretching to every horizon. These Cold War giants, once the most feared weapons on the planet, now rest in silent surrender under the relentless bright daylight. Their distinctive double-hull designs and massive sail structures creating a surreal forest of rusted steel. Each submarine, measuring over 170 meters in length and displacing nearly 50,000 tons, represents the pinnacle of Soviet naval engineering, a weapon system designed to dominate the depths of the world's oceans. Today, these titans of the deep have been gathered for their final mission, not war, but transformation. Welcome to the most ambitious recycling operation ever attempted, where thousands of nuclear submarines are systematically dismantled, sorted and reborn.
This section is severely compromised. Prep for depolution immediately.
Confirmed. Scanning levels now. They are high.
Marking the hull, ready for extraction.
Before any submarine can be dismantled, it must be rendered safe through a critical process called depolution. Specialized teams in hazmat suits and respirators board each vessel to identify and extract thousands of liters of hazardous fluids: engine oil, hydraulic fluid, coolant, bilge water, and fuel from the diesel backup systems. One of the most critical operations is the removal of the nuclear reactor compartments. Each Typhoon-class submarine contains two pressurized water nuclear reactors that once generated nearly 200 megawatts of power. Massive containment shells are lowered over the reactor compartments. Giant cranes extract the submarine's emergency lead-acid power banks, each battery the size of a small car, and transport them to dedicated processing facilities.
All right, next panel. Start with the power couplings. Copy that. Getting the extraction tools ready.
One of the most dangerous operations involves the careful removal of asbestos insulation from pipes and equipment, a process that requires sealed containment tents and negative air pressure to prevent contamination. Every fluid drained, every battery removed, every meter of asbestos extracted represents a step toward making these Cold War giants safe for the dismantling to come.
Watch it on the left side. All right, hold it steady there. Hold it steady. All right, bring it down slow.
With the submarines rendered safe, the heavy dismantling begins. Massive hydraulic shears, each weighing over 50 tons, bite into the steel hulls like mechanical jaws, tearing through the pressure hull plates with tremendous force. Giant excavators with demolition claws crush the sail structures, while teams of workers with oxy-fuel torches cut through massive propeller shafts. Cranes lift entire hull sections, each weighing hundreds of tons, and place them onto flatbed trucks or directly into the shredder feed hoppers. Inside the submarines, teams carefully remove navigation systems, communication equipment, and control consoles. The crew quarters, galley, sonar room, and torpedo room are systematically stripped of their equipment. Every wire, every circuit board, every electronic component carefully extracted, sorted, and prepared for precious metal recovery. The submarine sections then reach the primary shredding zone, where massive industrial shredders consume the hull sections with insatiable hunger. Enormous rotary shears reduce the steel to fist-sized chunks, while secondary hammer mills pound the fragments to uniform pieces. Powerful air classifiers separate the light materials, plastics, foam, and insulation from the heavier metal fragments, while dust collection systems capture particulates. This is the moment of transformation, where the Cold War giants finally lose their identity, reduced from massive structures to uniform fragments, their history erased in a burst of crushing steel. The shredded fragments enter the cleaning section, where rotary trommels use high-pressure water to remove loose salt, sand, and rust flakes. The fragments are then immersed in chemical wash baths, their surfaces stripped of oils, greases, and fuel residues. Mechanical abrasion and acid pickling remove the surface rust, exposing the bright metal beneath. The cleaned fragments then enter the separation phase, where powerful magnets pull the ferrous steel from the stream, while eddy current separators use rotating magnetic fields to repel aluminum, copper, brass, and bronze. Density separation systems further sort the materials, creating pure material streams. Steel on one side, aluminum on another, copper on a third, each one a valuable commodity ready for its next life. Non-metallic materials are also processed. Plastic granulators reduce interior trim and insulation to uniform flakes. Rubber shredders process seals and anechoic tiles into rubber crumb, and wiring harnesses are stripped of their insulation to recover copper wire. Textiles and foam from the crew quarters are shredded and baled for recycling.
This batch here looks good. The aluminum content is high grade.
Confirmed. The analyzer readings match the tablet data. We can clear it for the furnaces.
The recovered materials reach their final transformation stage, the furnaces. Steel fragments are charged into massive electric arc furnaces, where electrodes create blinding arcs of electricity that melt the steel to over 1600 degrees Celsius. Oxygen lances remove impurities. Alloying elements are added, and the molten steel flows into continuous casting machines, solidifying into billets and slabs. Aluminum melts in reverberatory furnaces and is cast into ingots, while copper is melted and cast into rods, and brass, bronze, and titanium into specialized forms.
Readings look good on Sector 4? Confirmed. No internal defects detected. All right, stamp it for QC Pass 2024.
Finally, the materials are packaged for shipment. Steel briquettes loaded onto trucks, aluminum ingots onto trains, copper rods onto ships, and precious metal concentrates into secure containers. The materials of thousands of Typhoon-class submarines now spread across the industrial world.